Hello dear friends, welcome to my YouTube channel. In this video we will see why the limits are so important in this calculus. And before going to the actual why the importance of the limits, let us go with the algebra of limits and some of the examples. And on this note, hi, my name is Trupti Bidwe. What is meant by algebra of limits? Algebra means it is the basic operations. What are the basic operations we have? Usual basic operations are addition, subtraction, multiplication and division. These are the basic operations, and with these basic operations we are dealing with these limits of functions. Means in this algebra of limits we have two functions. We can generalize that two functions into the n finite number of functions. We are having two functions and two limits. Means we are, suppose f is a function whose limit is L, g is a function whose limit is m. Then operate addition, subtraction, multiplication, division and scalar multiplication on these limits, and let us check the result. For that purpose, suppose I am having two functions f of x and g of x be the two functions, and limit of f of x as x tends to a is L, suppose, and limit of g of x as x tends to a is suppose m. As in the previous video we have seen what this limit of function exists. What does it mean? As we have seen in the previous video, f of x is one function and its limit as x tends to a is L, and g of x is another function whose limit as x tends to a is m. Then algebra of limits. First one, addition of these two functions. What is the limit of addition of f of x and g of x? F of x, g of x, f of x plus g of x. What is the limit? Its limit. First of all, separate the limit. We obtain limit of f of x as x tends to a plus limit of g of x as x tends to a. Separate the limits. What is the given? They have given limit of f of x tends to a is L, limit of g of x as x tends to a is m. Means it is L plus m. Means we can say that limit of sum of functions equals to the sum of their limits. Okay. Similarly, for subtraction, limit of f of x minus g of x as x tends to a equals to limit of f of x tends to a minus limit of g of x tends to a, which is equals to L minus m. That is limit of difference of the functions equals to the difference of their limits. This is for addition, subtraction. Now what is the limit of multiplication of two functions? Limit of f of x into g of x as x tends to a. Again separate the limits. We can write it as limit of f of x as x tends to a in multiply by limit of g of x as x tends to a. What is limit of f of x? X tends to a, it is L multiply m. That is multiplication of limits of the function equals to the multiplication of their limits. That is limit of multiplication of function equals to the multiplication of their limits. And third one, what is limit of k times f of x, where k is any constant as x tends to a. What we have obtained? Taking this k is constant, taking outside, we can write it as k times limit of f of x as x tends to a, which is equals to k times, what is limit of f of x tends to a? It is L, k into L. Okay. And fourth one is the division. Fourth one is the division of two functions. Limits of division of functions as x tends to a equals to the division of their limits. Limit x tends to a f of x divided by limit of g of x as x tends to a. What is the value of limit of f of x tends to a? It is L. Limit of g of x tends to a, it is m. Where what is the restriction? M must be not equals to 0. Because m is 0, 1 upon 0 infinity, means this is the meaningless. Therefore, limit of limit of division of two functions equals to the division of their limits. Okay, this is called the algebra of limits. Addition, subtraction, multiplication, scalar multiplication and division. Now let us go with the some notes and then we will go to the some examples. Let us go with the note. First one. What is limit of f of x? Sorry, instead of f of x, suppose constant. K is any constant. And what is its limit as x tends to a? It should be k. This k is independent term. Here it does not contain any term which containing x. So its limit is k. Limit of constant k is constant as x tends to a is k. Second, what is limit of x as x tends to a? Suppose x is any polynomial. Then what is its value? Substitute x equals to a here. We obtain a. What is limit of x to the power n as x tends to a? It is same. Instead of x, we are having x to the power n, polynomial of degree n. It is a to the power n. What is limit of rth root of x as x tends to a? It is rth root of a. And last one is, if suppose p of x be any polynomial, suppose p of x is any polynomial, then what is limit of p of x? X tends to a is p of x, replace x by a in this polynomial. Okay. Now with the help of this algebra of limits and these notes, we are going to solve two examples in this video. Let us go with the first example number 1. Limit x tends to 1. Limit x tends to 3. Root of 6 plus x minus square root of 7 minus x divided by x. Square root of 6 plus x minus square root of 7 minus x divided by x. As this is first, see, observe the numerator. Numerator is nothing but difference of two functions. And in this algebra, first property, second property. First property, difference. Limit of f of x minus g of x tends to a equals to limit of f of x tends to a minus limit of g of x tends to a. And this division property, algebra of limits, property number 4. What is that property number 4? Limit of f of x upon g of x tends to a equals to limit of numerator x tends to a divided by limit of denominator x tends to a. Provided limit of denominator should be non-zero. What is limit of x and x tends to 3? This. Second note, limit of x tends to 3. It is 3 and 3 is non-zero. So we can apply the limit. Okay. Now let us use both these algebra for subtraction, algebra for division. We obtain, we can write it as limit x tends to 3 square root of 6 plus x minus limit x tends to 3 square root of 7 minus x divided by limit of x as x tends to 3. Now simplify. What is its limit? Square root of 6 plus 9. 6 plus 3. Substitute x is 3 here. Minus square root of 7 minus x is 3. What is limit of x tends to 3x? This pronote, it is a. A is nothing but 3 here. What we obtain? Square root of 9 minus 7 minus 3, 4 divided by 3. 3 minus 2 divided by 3, which is equals to 1 by 3. 1 by 3 is the limit of this function. Okay? See, this algebra and notes we are using to solve this example. Now let us go with the one more example. Find out the limit. Example second. Limit x tends to 1. 1 upon x minus 1 divided by x minus 1. Okay. Now if we check, if we put x equals to 1 here directly, what we obtain? Numerator 1 minus 1 0, denominator 1 minus 1 0. Means we obtain 0 upon 0 form, and which is meaningless in mathematics, as we know everyone. Okay. Therefore, now question arises how to obtain the value of this function. No? See, as at x equals to 1 directly, this function 1 upon x minus 1 is not defined. No? Why it is not defined? Because we obtain 0 upon 0 form. Therefore, at x equals to 1 directly this function is not defined. That's why we use the limit to solve such a type of examples in which numerator and denominator gets 0, means we obtain the 0 upon 0 form. Okay. Now again here, first of all simplify this. Limit x tends to 1 upon x minus 1, this can be written as 1 minus x upon x minus 1. Again this can be written as limit x tends to 1 minus x upon x into x minus 1. Observe this, numerator contains 1 minus x, denominator contains x minus 1. Do some adjustment. Taking out negative outside, we obtain x minus 1. Now this x minus 1 cancel. Why it cancel? What is the reason behind the cancellation? This implies limit x tends to 1 minus 1 upon x is nothing but, substitute x equals to 1 here, minus 1 upon 1, which is equals to minus 1. Therefore, what we obtain? Limit x tends to 1 upon x minus 1 upon x minus 1 equals to minus 1. See, why we cancel this x minus 1? At x equals to 1, it is 0. Whether we cancel 0? No, we cannot cancel 0. We can cancel numerator and denominator same number or same term if it is non-zero. Why this is non-zero? See, limit x tends to 1 means x is very very close to 1 but not equals to 1. Whenever x is very very close to 1 but not equals to 1, this should be non-zero. And same for denominator, it is also non-zero and it gives a non-zero number. We can cancel to both sides, numerator and denominator. Okay, this is the use of limit to solve the function. See, this function is not defined. This function does not give the value at x equals to 1. Though it does not define at x equals to 1, still we can find the limit of this function as x tends to 1. This is the use of limit in calculus. Okay, I think everything is clear in this video. Thank you for watching my video. Stay safe, stay healthy.